All right, simple example problem here of a charged particle enters a magnetic field and it gets curved around as it enters a magnetic field due to the magnetic force on it, and it goes in a circular path. They want to know what's the radius of the path. The big thing here, what you have to recognize, is the magnetic force, the force sub B, the magnetic force will become the centripetal force. So we're going to finish this problem. This is not how we start, but we're going to finish this problem something like QV sine theta B will be mv squared over r. That's important to recognize somewhere. The magnetic force, QV sine theta B, of course, they're perpendicular, so that's going to be 90 degrees. So that's going to go to 1. So basically, this is going to be QVB equals mv squared over r. One of the v's will cancel out. So we'll end up with QB equals mv over r. That's really where we're going to finish up. But it comes from here. But we still have to get there. If you read this, they say, oh, a charged particle of plus 1e. Plus 1e is really 1.6 times 10 to the minus 19th coulombs. That's important. That's Q. We know the mass. We're going to need Q. We're going to need mass. Mass, we're told, is 2.5 times 10 to the minus 26 kilograms. And here they're telling us the potential difference. This thing gets a potential difference of 250 volts. Enters a magnetic field of a half a Tesla. Calculate the radius. All right, so we're given Q, we're given B, we're given M. We want to solve this thing for R. We need V. We need the velocity. So from here, we have to figure out how to get the velocity. Well, they talk about this particle that gets presented. Remember one of your last labs, the capacitor plate lab. You had a charged particle. There was a couple of plates. Here was a plate here, there's a plate here. Charged particle. There was a potential difference between those two things. Here we now know it's 250 volts. Right? Let's say this is the positive plate. This is the negative plate. So that positive thing is going to be accelerated across this potential difference here. Over here, it has lots of potential energy. Over here, it's going to have lots of kinetic energy. When it gets over here with all this kinetic energy, it enters the magnetic field. Maybe the magnetic field is into the board. Maybe there's a little hole in the capacitor plate there. So this thing, whatever it is, will zip through here and enter the magnetic field and get curved around. If that thing is positive, it's going to get curved around that way. Think of your right-hand rule. Thumb would be going across the page, fingers into the screen. Your palm would push it all this way around there. You want to know what the heck is that radius of that curvature. Okay? But you really need to know what speed this thing has when it gets over there. So here you have to have the potential energy of this. This you might remember, Q delta V becomes 1/2 mv squared over there. We have to figure out v. This was from 2 or 3 weeks ago, just before vacation, before President's Week. We were doing this, how everything builds upon everything else. So the energy here, Q delta V, 1.6 times 10 to the minus 19th coulombs times 250 volts is going to be equal to 1/2 2.5 times 10 to the minus 26 kilograms times V squared. You have to do all that to solve for V. And if you did all that to solving for V, let's do the math. 1.6 times 10 to the minus 19th times 250. Well, that part is 4 times 10 to the minus 17th. We have to divide that, multiply that by 2, divided by 2.5 times 10 to the minus 26. All that's going to equal to V squared times 2 divided by 2.5 second E negative 26. That equals V squared, square root of all that. V equals, right here, 569 meters per second. So now we have V. Now we know everything. Now we just solve this for R. Over here, R will be equal to mv divided by qb. M, 2.5 times 10 to the minus 26 kilograms. V, we just figured out, 56,569 meters per second, divided by Q, 1.6 times 10 to the minus 19th coulombs, multiplied by B, 0.5 Tesla. You do this arithmetic. Times 2.5 second E negative 26. We get 1.4 something times 10 to the minus 21st divided by 1.6 second E negative 19 divided by 0.5. All of that equals 0.177 meters. There's your answer.